Okay, give me a second, guys. This is live, so you can talk to me. I'll see it, and then I'll have to jump over and look at it. This is a shear. Great. So live, I can't pronounce shear now. This is a shear field. Yeah, that's interesting. Shear and failure behind each other causing problems for me. All right, a shear field. Moving on. A shear failure. It's going to look something like this if you guys want to ever Google it. I got a delay here. On a typical just regular beam without truss, it's going to look like this. The cracks, I'm going to wait for this to catch up. So here's where the arrows are going to be a shear, what it typically would look like. Now we have truss systems that actually line up with our shear rate. Tonight's not my night for shear, is it? For shear field. Great. For shear, great. I have no idea where that's coming from. Maybe I didn't I ate too much pineapple. Okay, so that's what it looks like typical. As you guys can probably imagine already, we have this in our members. I'm waiting for the screen to catch up. We have cracks and I'm waiting for the screen to catch up. And I'll tell you what I'll do. I'll come a little closer. And then I'll wait 5 seconds, right? And let me see, somebody said something. Okay. 7.4 seconds, read ahead buffer. Okay. Thank you. Audio is perfectly synced. Oh, okay, cool. That's interesting. Thanks for somebody telling me that, Rick. This one says, probably says, get on with it. No delay for me. Awesome. It's right in my room and I got the delay. Thanks for telling me that. So I'm assuming that my audio, well, yeah, let's make sure that we're synced. I'm pull my hand away. There shouldn't be an image yet. I'm going to tell you what I'm going to do, and then we'll see if they match up. I'm going to start counting, and when I touch the page with the pen, we'll know if we got a delay. 1, 2, 3, 4, 5, 6. I touch the dot when I hit number 6. Can you guys confirm that? No delay. Right on time. All right, then I can't look at the, sorry guys, I can't look at my monitor and perform then because it's giving me a delay in my brain then. It looks like everything I'm saying is 5 seconds behind. Moving on. So going back to the paper then, and I'll look up now and then for questions. Matter of fact, I'll ignore the screen. I'll just blow up the questions. I can make the screen larger for questions only. Great, you can't do that. Hold on. There it is. I can do it. Come on. All right. So now I can see questions only, and I do not see my screen. I'll just look through the camera. So shear failure looks typically like this if this was all solid concrete, not reinforced. Why does it kind of help us? Because we have columns that are diagonals that have, if you go back to all the images, we have diagonals with these cracks in them. They also are in line with the reinforcement on number 11. Keep that in mind. On number 11 it's lined with, I'm not sure how it lines up with number 1, if it also has it in line with the location of the reinforcement. In other words, the reinforcement could also cause this. If you're compressing the reinforcement, it could flex and come through, as we know. But, I don't like coincidences, but yet I still investigate them too. We have now I'm looking up at the screen. We have now a typical shear failure in a solid member looks like this. And doesn't that line up if we were to put in our steel, our members, our truss members? It lines up with that. So you can't just say that they're steel only. You have to say, wow, could they be a shear failure, and if of this whole structure, that is the dead load, the dead forces will be looking like that. You can do forces with a F or a P. So is this structure, are the dead loads creating shear failure here in this one? This is what's so important. This 10 is important with the cracks in it, the 4 in it. But then we have this one lining up with that. So let's watch this little surprise I have for you guys. And If you recall, we have, I'm going to do a rough drawing because this is this way. This is going to be the pier, right? What I'm calling the pier or pylon. I think I had to change it from pier in one of my videos because I started referencing it wrongly. So we're just going to do a rough idea of, first let's put the, I'm looking at the camera here. So, and then this will show what we're doing here. We're going to put the deck in and we're just going to be very clean about it. And what we're going to show is that this is a contact point on that pier. If you guys go find videos, you'll find a contact point here. This will be referenced in the video I'm making now. And then we have the canopy. And then we have the canopy top rather, and this is 12. So this becomes 12. This is the canopy. Everyone, and we've got these problems we have. Everyone's seeing pipe standing up here at the bottom of the deck, and they're seeing rebar up here. And no one can figure out how this rebar and reinforcement is in place without what's not being sheared off, that it wasn't just sheared off, crushed, bent over, right? I have the answer for that. And you guys are going to love it with cardboard. And I think I triggered somebody with my cardboard, but tough luck. Cardboard is the answer for me on this video budget, right? You know, I have a sense of humor, so if you guys hear my humor, you can troll me. I don't care. I like it. Hello, Hermit, old guy. Okay, hello. All right, so Hermit, yeah, I'm not sure if you can. Hermit, tell me, are you seeing me right now, or are you watching a beginning of a video? So right now I'm writing Hermit on this piece of paper. Let's see what Hermit sees. Cardboard is cool. Thank you, Daniel. Hermit, did you see this, or are you behind? So we'll see if people sign in. What do they get jumped to the back of the video? Yeah, let's move on. And I gotta feed the feed. That's what's going on here. Last I saw was Danielle, a comment. And give me a second to enlarge this. Yep, no, that was it. Cardboard is cool. Now, we're going to explain why these members are in place. At the same time, it's going to have to show you the entire failure. And it's going to be so simple. Let's get going. And let me back this up. And I'm going to have to move this around. How much would wood work? Now, wood wouldn't work on this, actually. How much would chuck? Hey, all I got to do is say sheer failure. And I got my woodchucking joke. 1. Okay. All right, so here's the pier. This is going to be the pier. So I got a marker for you guys. It's a pylon, rather. And sorry, I don't have a different marker. If you guys want me to get a different marker, just scream out and I'll go find one real quickly. So that's the pier. Here's our deck. Now I'm going to shift this around and you guys will know where it is in relationship to everything. Let's take out number 11, or let's do a quick rendition of it and you guys will get it. Here's number 10 in here. I think my cat took number 10, believe it or not. So 10's going to have to stand in for a piece of paper just now. 10's going to become a piece of paper. Back of envelope model. No, this is the back of a United States Postal Service box. I get your joke. No, bear with the back of bottom, guy. You're going to love it. All right, bear with it. Local 223. What is that? Steel? What is that? All right, so this is 10. It's all apart now, but let's give you a quick rundown of it. So we know that that's going to be a bottom connection. This is our top node. Let's put it in the failure mode. This 10 will be falling something like that. Let me make sure you can see it. We pull 10 out. 10's not important at this time. We know that 11 is gone, but 11 is down here. 11 is like this. If you guys just saw what happened with that post-tension cable, you're going to probably get ahead of me. So bear with me. Bear with me. And as you can see, this creates a lot of drama to get together. So now I've got to put my pier back up here. And you guys will watch what happens, how this reverses. Let's see. Yep, you can see it. All right, what I got here? Question. Is he trying to get fancy on us? Oh, this is all high dollar stuff here, Danielle. All right. This will explain the cable. Remember the cable ripping out. Let's move these out of the way for a second. We'll put them into play. Believe me, this took hours for me to get it down to this complicated of an issue. Let's put it back on top of the pier. And we're only going to deal with this. And this goes here and here. And now I will have to grab another pen, I think, to give you guys a visualization of those pipes. Give me a second to grab one. Okay, so then we have the pipes. Let's go ahead and do those pipes in real quick. And I'm only going, I'll do them here and here like this. Let's just do 2 of them. Sorry about, I don't know if I'm in the way there. And let's put some obstructions in here too. That's the rebar in this case. That sits on top of, nope, rebar's down here. So we have obstructions up top here on the deck. Let me look at my, I almost saw a delay and screwed myself up. We have the, as it's on the ground, you guys remember, everybody, NTSB is showing themselves right here, and we're looking down into a hole where this post-tension rod is still sticking out. On the top of the pier, we see like unhurt or undamaged, yeah, I'm gonna stick with it now, right? No, I need to change that. We see rebar appears to be non-deflected, non-moved, not bending out north or south. How do you get this off of here without damaging it? One of my previous videos, you guys might have noticed I said something about a hinge here. Watch how this would hinge. Let me pull up a little bit. Only focus on this. Let's move this out of the way. You guys are, yep, everybody's with me? So watch if I pull this down, how it lifts off. I don't move this from here. It becomes a hinge point. As it rotates out, do you see how it just pulled away? It just lifted off of the obstructions. And that's why you see the reinforcement standing up straight, and NTSB is looking down, and everyone's like, I don't get how those pipes are so not damaged. And I'll give engineering tips a little hit on that one, that they keep trying to figure out, well, how did that not get damaged? Well, here it is. I know a lot of those guys are, a couple of them are structural engineers and all that, but they need cardboard. They got to get with the program. All right, I'm teasing, of course, but you see cardboards, you're hinging, it lifts off. It's done. Now we have reinforcement here also that goes further back. This is where the pipes are, coming up number 12, the plastic pipes that are undamaged. It does the same thing. Now watch the action. If they're together, it hinges, lifting off. See my tape? Lift off. Now it's off. So now this explains why we have no damage in the NTSB video, no significant damage on those plastic pipes and all. Anybody give me a hallelujah on that? I'm not religious, but just want to know if anybody's paying attention on that. I'm looking at I get it now. That's that guy. The little creature. Fester and all. Now, let's go ahead and put this down on the ground without adding the other sections yet. So let's back this up. And let's start our failure. Again, I think the failure, let me get this over here, is dead load. Because we have documentation from Morales, I think it is, the DPA. If you guys looked at that last video, I showed that, or one of my 4 videos I loaded all up at once, I showed that he said there was cracking after they removed the formwork. Kind of like pulling it out a nail board. Yeah, I'm with you, cousin it. So he said there was, here's our structure, the bridge, and we don't have to care about it. So here's our force, our dead load force would be pretty much in the center if we just disregard their design. And so this again, as I mentioned before, is pulling away here, and that's what that one crack analysis I said is. But we've got those cracks going up, and we got cracks coming here, I believe too, because what they released from FIU, they wanted us from over here. Remember, FIU's got skin in the game, right? They don't want to. Believe me, they're not. That's their people they're talking about too, because 40% of them came from their school. In reality, the Morales' paper clearly stated that this had cracking in it before they post-tensioned. And that was, if you go back and look at the notes there, that was somewhere around, it was closer to 14 or even out there in there 20-something days, I would say. It doesn't matter because you had cracking beforehand, and you remember they took things off. But That's sort of digressing. That's showing you that this thing couldn't hold its own load before post-tensioning. And that's like so obvious, right? It couldn't hold its own load before post-tensioning, the top and bottom, or the zigzagged diagonals. Of course, you think it could not do that, right? And if that's the case, what did they think? They were testing to see if the structure could work without post-tensioning by removing all the formwork. And when I say all of it, I went over that time lapse over and over again and tried to slow it down. It's so hard to do. And I like to throw that at you guys too. They had a time lapse video on this whole thing. Nobody's found that video of a collapse. I mean, we're all looking for cameras and everything. The time lapse is there, and time lapse are freeze frames. Keep this in mind. Time lapse, we see it as it's whatever the guy made it, the time lapse. I'll jump into the photography thing. I may do a time lapse and I'll say I want 30 frames per second. That's pretty much standard, but I might change it to I want 15 frames per second, which makes it half speed. And I might say I want 10 frames per second. So every 10 seconds, rather, 6 frames a minute, I have an image. But then we compress them all and we make a super fast video of it. In other words, there's tons of single images of this collapse if that camera was still in play, which it probably was. So there is a lot of data to be grabbed from that time lapse. And I mean literal images, not a video. They're literally photographs. Category how and style. How and style. Okay, is this my rat boy? What's up? I don't know how to change that. Everybody's following this under FIU. Okay, back to this. So we're talking about the dead load. So I'm giving you the force, because we need a force, an acting force for it to move, right? And we're going to use dead loads on that. Okay, let's just go with that. We're not going to use the guy's post-tensioning, incidentally, which the post-tensioning company just would not have touched it. They wouldn't have been liable. They just said, no, I think we need to make the structure sound. But they got up there and they put their hands on it, so that makes them liable. And that's it. You know, they're party to it. And if they can somehow show that they weren't, I'm moving on with that. They were crack adjusting, crack fixing, I think, per Denny Pate's orders. He's the structural engineer on this job. He would have told, the engineer on the job. He would have been ultimately making this decision to post-tension. Okay, I think somebody said, I think what you have figured out is what happened from everything I've seen. Yeah, Danielle, but watch how I'm going to show you the bridge pulls away, pulls back in, and you're going to, if you will look at the NTSB images, you'll find right here, let me make sure it's in the video. Yep, so this will be the pylon. Right here is a contact point. You think nothing of it. There's no contact here, and all of a sudden you see a contact point. And then the deck is here. Let's put the deck down there. So the deck is here. When it fell off, it fell away. As you can see, it would just fall to the ground, right? At some point, it came in, maybe it bounced off, it came in, and continued down to settle in place. This shows movement. This shows that when it came off, it had some clearance, and all of a sudden it changed directions, and then here, and then down it went. And this will come into play trying to figure out what broke first, the canopy or the lower deck, or did they broke simultaneously. And I slowed down the video. I slowed down a slow down video, and I slowed it down again and again, and that's the video that I'm having problems with trying to render for you guys. It looks simultaneously, which would then put it to dead load, which will also state that number 10, as we see no deflection in number 10, it would state, my theory is stating that if there's no deflection in 10, that means it pulled so look, if there's no deflection in 10, and just don't even worry about 11 yet, that these are bonded like the plate thing. But not, these guys are post-tension in this direction, right? So I'll just say that PT. But this had 4 guys in it. Remember, 4 times 389 kips. It held perfectly, I think. It's top node, and I guess we can call it a bottom node, if we will. It held perfectly. So the dead load on this structure, literally flexing, or bowing, however you want to guys look at it, deflecting. The dead load on the structure is the mid-span. Let's do that again. So we're at the mid-span here. We've got some deflection going on. Remember, that causes an opening here, as I showed or I described. It could do easily. At some point, it breaks the canopy in this. I think this guy's perfectly together. I mean, they're perfect. It's simultaneously happens. But we still have the weakness. And so you need, we cables, they didn't separate from the canopy. They stayed there as it pulled itself over. And let me look at the comments in a second. Let's just start here. I think the canopy was first. Yeah, I hear you, Danielle. I've slowed down a video time, slowing it down again in software, and then slowing it down again, and that takes a long time to view that. It creeps. With that, I couldn't see a difference. And I think I went over that in one of my first videos, looked at it broke, and that caused the deflection in leaven and things like that. I don't see leaven. I see leaven hinging here, which explains its damage down here. We even see a J-hook that's in place, which I might have commented on a previous one. No damage, no compression on it, which explains itself for anybody just jumping in. Explains itself. Let me just jump to that and jump back because this is live for people. So we're going over, let's see. I'll tell you what, if you just jumped in, you got to say you just jumped in. And then I'll jump back and do that one little shot again. But we're showing, and I'll do it. Let me do this. Let me do this. Bear with me. Nope, I'm not going to do it. I was going to say if you jump in, just let me know. What I'm showing again is that this hinged off. As this came up. Now, Danielle, here's the thing about it, right? It's going to have to accelerate to do this. Because Danielle's the one who's jumping the gun a little bit. I'm going to fire her. So look, to do this, what does that mean? That these two have to separate from each other. They just can't fall together. So we do need that break to happen. Okay, what we got? Danielle trolling me. Eric, hey guys, just jumped in. Okay, good. Eric. I saw the title and it caught my eye. I'm in the industry. Okay. So I'm not looking up all the time at your comments. I'm just flashing up now and then. So to jumping again, to take care of this reinforcement here, this does this. To do this, look at the common sense. These can't be together. We need this to go, right? We need it to go, and can it go faster on its own? No, this needs to accelerate faster. The bottom deck needs to go away first, and then cause this rotation. We're gonna get there. We're gonna get the rotation for you guys. Let's back it up. Now you see why it took an hour to do that video that I couldn't get together. Well, it took way more than that. So let me see where we are. So here's our guys post-tensioning, right? And there's the other structure. Where the cuts are, these are, let me separate it so you can guys see it a little better. These are where the breaks are, and I'm going to show you, I got to find my other member. I'm going to show you how this comes apart and how you even get that tail, this tail, if you will. And don't be afraid to jump in and ask questions. I might jump ship and go directions on you. Eric, I saw the, okay. So we need to get this to break. So we get the force. Our force is dead loads. So somebody just said something, is what you're showing us a cross section. Everything could be a cross section at this point, right? So you're looking at a cross section of it, and I wouldn't know how else, what you think a cross section is, so I don't want to confuse you. I got to find 10. Give me a second to grab 10. My cat was playing with it. Actually, Danielle, this was my cat that gave me the idea. He told me about the bird. Danielle would like that. She's been bothering me with my bird. The invisible bird. The invisible bird that I mentioned as a semi-joke is what the NTSB would love to find, and also the builders would love to find. An invisible bird weighs 2 tons. He landed, or she landed, or it landed on the structure. Nobody can see it. It created the force and caused it to collapse, so nobody's at fault. That's the invisible bird that they would love to find. Okay, so watch what happens, and you guys will put it together as I do it. Watch what happens as this starts falling down. I gotta get them kind of close together again. Let's start our moment, our rotation. And let's move that one out for now. Let's start this going down. Let's put this back together. This is definitely not the scale. What you notice is, let me see where you guys are. You see the opening? All right. Yep. Let me see what somebody says. I have no idea what this says. Let me see something. It's saying something on the computer. check out my YouTube channel. Oh, whatever. Somebody's trolling on top behind this. It's cool. View deleted message. All right, so what you show first is that this is what a tension break looks like. The load's here, and this is compression, and this is tension, pulling apart. Looks like that. You have it here also, right? Because by default, this is going down. Now you see it's together. By default, it's going down. If we let's eliminate buckling. Buckling is after you determine the maximum loads a column can take. It's considered the column. Then you check it for its buckling capacity, when it's going to buckle. Diagonals buckle sooner, unless you had the post-tensioning in there. We talked about that, but they made the post-tensioning equal on this, so that eliminated the post-tensioning being designed to resist this force down here, this opening force. And we know these, we thought that we know them, or we think we know them to be at, this is 389, 209, 109 difference, I don't know, something like that. It's two of them in here. But it opens here. Look what happens when it starts opening here. It starts elongating this cable, the cable the guys are working on. They're still on the bridge at this time. I don't think they got much work done when this one failed. And with that, let's back this up. Let's put compression back on number 11, the top 11. Let's jump to that. This has already been completed, supposedly. It's fully under compression. It's closed up whatever it can do. It's doing whatever it can do. Right? It's done. Now they move over to this one. They start loading it. The resistive forces in number 10, we know by Morales, said that they caused cracks in the in number 10 at multiple locations. 1, 2, 3, 4 that he disclosed. Right? So that he disclosed. Irrelevant to us. Irrelevant because as we watch this in the video falling, this thing does not buckle. It does not change shape. And another message. Again, I'm sorry about, what's this? Again, I'm sorry about jumping in. Go ahead. I know the bridge was essentially a ready-made structure installed this short amount of time. Was completed before installing. So all post-tensioning was complete? No, it was not. Definitely not. You're going to have to do some, Eric, you got to do some video searching on that. I've talked about that, but no, Eric, and just, you have to play the blind man for a minute, go along with it. So we're just moving this down, just have this collapsing on its own. You see now we get further elongation, and now this, at some point, can no longer take it. It doesn't really matter when it can no longer take it, because I don't think it's the initiation of it. Remember, if it was compressing, we'd have to initiate. The only thing it could do, because we don't notice buckling in the videos, it would be on the bottom, and we don't notice in the NTSB images, we don't notice this damage from here down to here. AVA was right. We've all said it was mid-span failure initially until we saw the video. Everyone knows that all spans pretty much fail under shear. So what I said here is it's not really a brainstorm and nothing. It's a shear failure. It's not that. So every mid-spans ultimately they either fail in the center, just letting you collapse fully through, coming off their pylons. But in this case, we have it coming off 11 down at this end here. This is what makes it so important. Let's move back. Okay, local 223. Where are you? Did you answer what union that is, or just that's your name? All right, none of my business. I stand corrected. It's YouTube, man. Don't answer that stuff out there. So let's go on. So now let's just leave this where it is, and let's just make this collapse on its own. Can't do anything. We know it can't do it. We know that it collapsed. It also broke down the bottom. Lead. Lead as in that stuff that kills you? Lead, that type of lead? Lead remediation? Okay, well, the damage on the pylon could have been 10 hitting the road. 10 hitting the road and stopping the upper 10? Okay. 10 is over here, just so you guys know. 10. It's nowhere in proximity. I'm going to tell you how the pylon, the damage on the pylon is just an indicator of the path. The load path is what it's about. It's nothing that crazy about. Move that out of the way. So now we're up there, what, 65 people. So let's go ahead and let's jump into this again, back over here. Now, where we're at now, we're showing that you have no damage. It's just a hinge action. Hinge action. Let's go ahead and pull this out of the way, and let's pull it, and let's leave the node out also. Let's go ahead and let this pivot off the top of this. Pivot off the top of this. So we got our brakes here and here. I guess you got to get a little more visual than that. Sorry about that. Sometimes I'm a little assuming too much. So we get our brakes here and here. That means the bridge has we know the path. It's coming down. Now let's watch it do its thing. So it comes down. Let's keep it in direction. Now let me back that up. The math, yeah. So now we're back to the pylon again. Here's your pylon. Here's the pivoting point. It's already lift off now. If you can see this rotate, the bottom of this, it's already lift off the rebar, the reinforcement that's there. And that's why we don't see it shearing off, because it first rotated lifting off of the rebar. Now we've cleared that rebar. It's not an issue. It's no longer an issue. Now we're going to get the, but we have this, the part that if you look at the video and I showed that this seems to compress. And I did something like this to show it in one of the videos. It didn't work. But if it compressed, it can't fix itself. And if you look at the finished details, this is not broken. So the compression that I said it's for distorting and bending down, I was looking for a joint here that would allow that deflection. No, can't find that. But what I could find was, if you watch this now, we're going to introduce some type of a shifting moment. And I would, who's that guy just said something about AVI? Oh, yeah. So local 223, you would love that then if I said shear here, right? So let's rotate this and create a shear sideways action. See, I used it for you guys that way. All right, so it's not shearing. This is a hinge. And as it's falling down, so we're coming down off the, make sure it's in the video. This is the top of the pier. And let's pull this away for a moment. As it's coming down, no, it's coming down, right? This is the one end of the bridge, right? This is the part of the video drove me crazy. So now I'm going to double this up as the other end of the bridge. Look what happens. It's going that way only. How can this go that way only if the other side's coming down also? It cannot. And that's what I showed where you guys saw the video where I showed it was actually gone this way for a moment, out of alignment with the pier, overhanging the pier the other way. And that got a lot of people upset. I mean, you guys don't see some of the comments I see. It's okay. Look, if that it went this way, so now we're off of this again. So we're on, and then we're off. So now we're just doing this cable up really nice now, but we're also doing some damage down the back of here. At some point when it does this, all right. So what did it do there? Remember the detail on the back of this bridge has this little nodule, a little extra part coming down the deck. Well, when it rotated there, it caused that to be under tension and compression and just, you know, disintegrated that little piece there because it appears pretty smooth on the, as I recall, as we look at the NTSB images, it's just a smooth back left now. It's not that extra piece, this right here that's going down. On the outside, it sticks out something like this. You know, that, and I put a little dots there, sort of simulate it in the wrong position, but, well, maybe it is in the right position. Questions? Let's see, Hermit. I think they did the math of it. Right, so that. Okay, so now how do we get this? Let's go to, gosh, I wish I had a good video, a video that worked. Give me a second, reaching over. Let's grab this piece of lumber. Great, it doesn't fit in the video. Awesome. Awesome. Like I said, let's grab this cardboard, this be real easy once you guys see it. Let's grab this, need something kind of square. Something square, give me a second. Oh, my head, hold on. All right, I told you I have a sense of humor. Got a piece of paper, there's something you guys can do. And you can play with this all night long if you want with a piece of paper. Let's move our little subject out of the way. Let's line this up with the lines of the flooring. Let's use this as a reference point. That's our reference point, that mark there. Let's grab another reference point. Come here. Okay, so let me bring the light over a little bit. So we have 2 points here, right? This we know, and this is the pylon at this point, right? And this is just a point to show you a very firm point. Yeah, that's stupid. I gotta move this over. And this is on the pylon. Let's just call it like that. And put this one right here. Look at this corner here. And then I've got to pin this with my finger, and I'm going to rotate. Now, I have not tried this with a piece of paper. I tried it with something else, but it's all the same. So as I pin it, do you see that the path it takes? It's outside of its original starting point. Yeah, line it up. So it's outside its original starting point. So you're going to get shifting of that coming this way, north, coming north. Now let's go ahead and move on from there. Let's come back to the structure again. And let's put that shifting in there. And you'll see how you get the separation and all this other goodies. So we'll put back this guy, put back that guy. I'll have the comments in a second. Give me a moment. Here's our number 10. And checking the camera, tilting up a little bit. Okay. Yeah. I think I'm using proprietary mail service. I thought it was UPS. Required, thank you for using Wait a minute. Patrick, did you send me a text message on this once? Somebody trolled the heck out of me with that. All right, so back to this. So now we got our brakes happening. And it can't fall in, as I just showed you. It can't just push in one direction because the weight of the rest of the bridge is greater than this little weight down here. So it's going to push back, as I showed you in the video. The greater side will push back greater once you get a brake. Once you get that brake, the greater side, the heavier mass side, will push back as it rotates off the top of its pier. It's going to push this direction. So the brake happens, right? And as it happens, this, remember I showed you like the piece of paper, this is going to push further out. Keep in mind the top of the canopy broke further north than the bottom of the decking. So you're going to get even a further distortion. So it would be more like when I use the paper, differently. See, it's rotating in, pulling in, and this is pulling out. So you're getting this different cam action going on. Moving on. He can mail his cut. What? Wait, I paid for that box. That was not a free box. I'll send it to Amazon. You know what they talk about? No, you guys gonna go down the wrong track on that. So look, anyway. So now we're almost there. There we go. So we start our rotation. We get our cracks. By default, it starts crushing in. At that point, it starts crushing in. We're still up in this position roughly. I'm getting a little excited now. It's still up in the bridge, still up high. At this point, the loads are more on towards the south side of this brake. This should be the north side. That's the south side. Once that happens, the south side's got more power. It's heavier, you know, fat person pushing a little guy. It starts to push back. It's connected here at the cables. Remember, we still got longitudinal cables, C1, correction, C2, C3, and we got all the cables down there. So they're tied in, and this thing says, hey, I'm trying to come off this pier over here because I want to hit the ground. And it says, no, you can't. No, you can't. We're connected still. And it never lost its connection, as far as I could tell. It says, no, we're connected still. And so they did a little push-pull thing. And before gravity took over even on the heavier side, the south side, it made it come down. No bullying. Right. So, I don't mind bullies. That's usually just they tell them what they're about. So anyway, they disclose themselves. Besides, I'm a psychological person. I like dealing with that stuff. So we come down this way. We can only go so much before the weight takes over. Now I'm going to use the south side to start pushing over. Are you saying that the cables... Oh, I lost your message. Are you saying that I had to read on the laptop. The cable... Are you saying all the post-tension cables in the canopy and deck failed to allow brakes? Yes, we don't see a full break. They probably elongate it. Remember, these cables are 175 feet long. They had to elongate. They followed each other with this. You can visualize it. You can visualize it. But they stayed together. We know at the bottom of the deck, and you got to bear with me on that. You'll see it at the bottom. They're together. Right there's the blister bar. That's sitting on top of the blister bar, not by accident, because they were connected by post-tension cables bonding them. And we're going to get to it. So that's your answer. And let's wait. All right, that's John again. All right, same person. I'm the same message. I'm pulling 10 out. Not yet. Sorry for that. It's still in the air. So it's still in the air. It starts pushing back. This is where it is. It doesn't push this one back at this time, I don't think. It's just more the top takes the load, because remember the cantilever thing? As it pushes back, now we're getting that shear action going on a little bit down here. And this guy gets shoved off. Remember that little piece? It only has shoved off so many feet. And that's when it what appears to be come down. Now it's below this. That's when the illusion is. And this rotates down because it's still got to go together. So here we go. So now it appears to be smaller. Remember, but it comes back and it pulls here. If you guys remember one of my videos, and I showed the traffic cam side of it, and I said, that's driving me crazy. At the end of the video, I said, why does it look like it falls twice? I said, I can't get that out. Well, I figured out why it looks like it falls twice. United States, thank you to my postal box, right? So anyway, we now have why this looks like it got smaller. It did not. It slid off to the side there. And the question is, I can't read it. Hold on. Let me just pull the laptop closer. Question. Isn't there simulated software? Yeah, you should look at all the simulated software. How does the simulated software do this? Everyone has been playing with this, no offense. Everyone's been playing with this for months. They got access to the thousands of dollars of software, which I do not have access to. Some of them have some really beautiful stuff. Computer guys especially, I watched a few of their images. It's none of them with all that fancy software, none of them have spoken about how that was able to stay. What is speaking about how that was able to stay? Cardboard. So yeah, I'm being a little biased. I'm not too much into software. I'm still old school. I use math and common sense. So here we go. So then we have this rotation, but we're still on top of the pier here. But downward direction of the bridge is going to pull this back now. It's going to pull it off the pier. Let me get us off the pier now. So as this still falls, this now gets pulled over. Now you see it sliding here off the pier, and we'll just move this over as we go, and we'll rotate. And we're going to have to clear the pier first. So this is going to accelerate faster. The bottom deck is. It's starting to pull away. I'm sorry. Let me take that away. It's not pulling away yet. All right, so then we've got something like this going on. All right, let me back this out. I want to make it to the ground more. I weigh more. I deserve to go more. It's being pulled. It hits the ground, and we're going to get a secondary brake. As it's going down, it then cleared this. As you can see, no contact. And we'll come down a little more on that one. Is an image? Yeah. At some point, content is going to get totally compressed. It's going to fail in this direction, I believe. And then this is going to sit on top of it. So I'll just let it start sliding a bit. And we're rotating. But now we're going to have to start. We're going to have to show the acceleration, deceleration. But I need this to stay up here. I guess I messed up. Hold on, guys. Live. Right. That's why it took me so long to do the video. Back up here. Back up again. And I'll tell you what I'm driving at. This stays on top, remember? Stays on top of the pier. All right. And this is what it's like. And a computer generation wants to keep everything together. Real life, we got the real data. So it starts rocking over, pulling over. Let's just do that a little more accelerated. I need this to pull away. The bottom pulls away at some point beyond this one. No damage done. It's clear. This drops down onto the top of the pier. And I'm going to get it, because now I'm back in shape again with the way I was. So we're back on top of the pier. And we're going to get our, Danielle, we're going to get our impact in a moment. But as you notice already, what's happening? The post-tension rod's ripping through the bottom of 11. This is now taking a compressing load. It's now starting to fail, whichever way. We don't really get to catch that in the images. We're just going to lay it there, like I said, and we're going to come on top of that. This is falling, rotating. I guess it would still be somehow crushing and forcing backwards towards the south. Let's remove it and just follow this. We now, at some point, the bridge, it now has cleared it, and what happens? Oh, sorry. It's cleared it. It's cleared this section here of the pylon. Now it can push. The bridge is trying to settle down. It's just doing the brakes in the road, etc. It taps this at one point against there, takes a little bit of a ride down, and skips. I think, because I don't know if it goes all the way down. It lightens up anyway. This is rotating around. Why do we know that the deck fell faster than the top part? Because we have the ripped out rod. We can't get this rod ripped out unless we have this going faster. If we have it going together, let's just keep 11 out. So we have this going together. We can't get ripping of the cable, can we? That's why we need the bottom of the deck. I'm not looking at any messages yet. Hold on. That's why we need the bottom of the deck to accelerate first, faster. As it accelerates, it starts ripping out, hitting the ground. It's continuous motion. We come around, and we're settled in place. This explains, and then we put the node back in, because the node was part of the resistance. Put the node back in, and we put the, they call it a blister bar. And here's our settlement. Something like that. Back on top of the pier. Get back up there. And this is what it was like. Don't try and do this video for an hour. So live is better. And I'm going to take some liberty here and move that around a bit. Top of the pylon. Move that down. Get over there, pylon. I'm not taking any more liberties. I keep trying to push this thing around and drive myself crazy. Hold on. Come down again. Get over there. Now, here's our post-tension rod sticking out. There. Rotation. I'll look at your comments in a minute. All right, comments. Let's see. That's right, Mark. So I don't think it could ever work. I don't think this could ever work. The math on this could never work. And there you have the explanation of the why the rod looks like that. You have the explanation on why we have no damage in the videos that they show NTSB and all. Well, it's no damage pretty much, insignificant. Why you have no damage on the bottom of the decking of the decking rather. Why we don't have any shear moment, because this was a hinge action going on, lifting it off, pulling away as the bottom of the bridge pulled away. Now, take note of that. When it pulled away, to pull away, if it was on this pylon and it pulled away, at that point, number 10's getting moved that away. It's got to get out. It's got to do something. It can't just shift that way without causing 10 to shear probably at the canopy, underside of the node. And as 10 did, as this pushed that way, imagine it connected now. So look at the action. Now you're getting tension on the bottom here as it pulls away. So people just jumping again, there you go. Guess you got to keep looking at the video. Message retracted. All right. Yeah, well, still, right? Concrete cracks. I don't think concrete should have been used in a truss system. You know, concrete. Everybody who installs concrete always gives a warranty that it will crack. So how are they doing concrete in a bridge with the flex and everything else? This is FIU's magical bullet of getting around. Well, as someone said, the union workers, the iron workers, the resources are really tough, and it costs a lot more money, and so they're going to make less money by using union workers, the steel workers, the iron workers, all the union people they need. Now, I'm not pro-union. That's where the skill is. That's where they do the training. So, this we saw so many problems with. Concrete should never be used in a flexural position. Thank you for explaining to us. Thank you, Daniel. You're welcome, rather. So, and thank you. If any questions about this and you guys that I can go over again, that hinge in action or anything that you guys might have seen I missed or I jumped something. Because remember, you know, even though you guys see a video, it only takes 20 minutes. This stuff takes me hours. And yes, it's consuming us all. I'm a victim of it also. I'm a victim of this structure too, right? We all are. So what we have, yep. And then pylon. So hopefully that explained it. You have to do some Google searching if you want to find my background, cousin it. I've got a lot of background, cousin it. A lot of things that I don't, I'm not that open. You gotta sleep with me. I know you're a guy, right? Hey, that's my humor. If they had left the post-tension rods alone, yeah, that would be an awesome, that's what I said in the beginning, Patrick, that, wow, this guy, if if VSL would have just stayed out of it, they would have been okay. If they just took to their grounds and said, if they had those grounds, saying that, you know what, we shouldn't be post-tensioning structures, too many cracks. Now, what gives them authority to say that? They are the crack experts, if you will, of bridge structures. So they can't claim ignorance. They can't claim ignorance no more than I can claim ignorance. You can't wear the ignorant hat. I was just following orders. You can't wear that if you're an expert. All right, well, you're that. All right. I car mechanic. No, I'm definitely not a car mechanic. But I think the human brain, cousin it, can do anything. Can do anything, cousin it. Even you, cousin it, can do anything. You could tell me how to remove that magic marker if you wanted to, off that floor. Anyway, any other questions? Besides cousin it having a little fun. Wait a minute, cousin it, you're a car. You're a truck. Danielle, hire a maid. Oh no, this is a construction site. You can see it in one of my other videos. This whole thing's being torn out. This whole thing's being torn out. That's what you see. That's what you don't know you see. Okay, 5-second delay. Okay, one way looking at notes. One way to repair it is attach a steel system. No, this is done. You know, it's good money after bad. It's just concrete. It was always doomed to fail. Could always try dry erase marker. So the thing is, first we establish what kind of marker it is. Is it a permanent marker? What is it made of? And then we defeat what the marker's made of. So if you want to go down that line, it says permanent marker. So we'd have to figure out what the material is and remove it. We know it's only topical, right? It's only on the surface. Maybe it's some fibers. You know, but anyway, so there's the marker thing. Materials, find out what it's made of first. That's my point. Concrete cracks. It's done. It's done. Concrete, it's done. Although there is a concrete material they're playing with. Or I guess you can't call it a material. The self-healing. And something I've been playing around with in my mind is salts are created in concrete. If I were to saturate your concrete with water, ultimately salts are made. Salts are a beautiful thing. I've got a few topics that I really consume me, and salt is one of them. Can you turn the salt, since they're made and they come out of cracks in the concrete, can we turn that crack and the salts into a structural element? I don't know how. I even contacted the Utah salt flats, and those people took about a week to get back to me with my crazy question about what, if anything, can live in the Utah salt flats. They got back to me and said, nothing lives there, nothing grows there, save one thing. What grows there? More salt. In fact, anything that goes out there, it says it dies. It dies. So there we go. So salt is something else. Okay. Yep. Okay, what's the next question? Post-tension bars were holding the bridge together. Yeah, I would say so. Because concrete's terrible in tension, and you know what? Glue was holding this bridge together. The span was too great. The slender factor, they made it too thin. Ultimately, it's just a failure with the failure design. and all about money, I think. It was all about, you know, FIU wanting to be famous, but more so about future of building bridges, that you can now get, you know, anybody to build a bridge. One of the places I drive by frequently, like 3 times a week, I see the guys building a bridge out there, and there's 6 guys on the job site. Sometimes there's as much as 10. It's really that bad with the workers. Okay, what do we have here? This is what happens when you're spending other people's money. Yeah, they don't really care, do they? Yeah, yeah, that's a thought, John. They spent it like it didn't belong to them. Yeah, it was about building the most expensive bridge possible. It was a YouTube 99. I bet you this grant money, which I can't find the original. Oh, I love to share this with you now. You guys should find the original bridge. No one's found it yet, and I've trolled over there and trolling mean looking over there in what's engineer tips, because P 2015 sent me over there one day, and I've been looking for the original bridge post there, so I can say got me before I could post it. I didn't want to get sidetracked with you guys, but the original bridge crosswalk for this was actually beautiful, and it was down on the ground where it would make sense, you know, just skimming across the canal. It looked like it was made of wood. Here's the kicker for you guys that are, it was going to be dedicated to 4 Cubans. Now I think they were in Vietnam. I got to find it again. They were in Vietnam. It was a good dedication, you know, no racism going on there. But all of a sudden that dedication disappeared. It's not, they weren't part of, I've yet to find where they're still a part of the dedicated crosswalk, this bridge, this structure. That was the first one I found, and it was pretty. But now it's hocus pocus. That is not, that dedication of those 4 Cubans are no longer there. And what do we have here? They look like origami. Sharing this. Yeah, so somebody said sharing this. With Pellin 7. Did you just jump in, Pellin 7? Because I think you probably missed the beginning here. This part here. If anybody missed this part where I explain how this cleared the members, then jump in. You know what? Let me do something crazy. While you guys doing that, I want, if you got, you can't share an image, so let me grab an image while you're doing that. And I'll try to look at my phone here. And for clarity, you guys can talk. I half see it. From location, Florida. You mean a few miles from where you're located, Pellin 7? Okay, where's the where is it? And you guys got the images of the where's photo 7? Photo 7. You know, that's got to be something else, or it's just a, you know, a red herring. We see, you know, this is what happened here. It's concrete. It's, you know, it's concrete, but heads should fall, and we already know that, you know, FIU's, and all the lobbying's going on. I'd love to find out what lobbying's going on. Oh, speaking of that, you know what? I got to share this with you guys. So I don't do thumbs up and all that. You guys always see them on videos. I don't have the thumbs up because I don't, you know, that's called validation. And then I could go on percentages. And now I'm looking for validations. If you guys ever heard of the slot machine effect, it's what thumbs up do. It's validate you or it doesn't validate you. Now, 80 people can give me a thumbs up. One person give you a thumbs down. And that can just, oh my gosh, you can just look at it, you know, all wrong. You can tell everybody, brag to everybody about your success. And one person says, I don't think much of it. That one person can hurt you. So this is because we're built that way. Now, validation. So what do you have here? This beautiful description of how the bridge fell. Awesome. Thank you, Hermit. Now, so MCM, remember I did that video about how MCM is can't follow orders? Now, I only get about 7 thumbs down, believe it or not, on all my videos. But where I said MCM can't follow orders, 265. I bet you we can figure out how many crew members work for MCM, right? Oh, that was, I was like, ooh. So, love your videos analysis. Thank you, Pellin. Anyway, this probably is going to bring it to my analysis. I mean, this now explains what we have left, what we were, you know, people were wondering about. And I go to those forums to see what they're wondering about, and then I say, let me give them the answer. So here's the answer to that. You know, it explains how it came off the pylon, why there's no damage. Explain my stepping down thing, and also why it looked like the bridge took a second hit down. I guess I should have said that to my girl. Where's my girl? Danielle. Yeah, it hit her nerve. So Danielle, remember I said it in another video, I said, so I guess when I did this earlier part of this video, maybe I messed up. Maybe this was the hold-up, Danielle. And then I said the bridge took a second fall, a second bump. That's maybe was that, Danielle? And then, boom, the rest of it went down. So what appeared to me like a sliding action was a sliding action, but the video caught it, stayed stuck, and then jumped down. All right, that's what I'm sticking with. That's my story, and I'm sticking with that one for now. And what do you say here? YouTube world, thumb up, thumb down, or up is the same. It's a view. It's actually right. They don't care. They don't care. They just care about description. Do you think the design would have worked if they had been able to build it in a place as opposed to ABC? So there is a British company, British representative building a bridge. They should be. I guess to build let me grab a piece of paper. To build this bridge, a bridge they were working on. This is how awesome it is. They went back. They're with arches. They're sticking old school. Arches are the shit. And I was going to get, and they built this arch structure, right? Now here are the loads that go onto the arch. So here's the deck. So the loads transfer. Let me see if I can get that for you guys. Old school. The loads, that means the entire structure is under compression. This is all under compression. Let me look at your thing. So this is compression. This is the way to go. Everything's stronger under compression. You know, you put some, not everything, I won't say that. So this is compression. Bridges have a history of being the strongest under compression. This is the way they did it. Now, you'll love this part. They set up the formwork and that's being facetious. They filled this all with dirt first. And we're talking, this must be 90 feet. They filled it all with dirt. Nice, safe working station. Then they just had to do one stage of formwork. Did this, let it set, cure it properly, do its thing. It's all in compression now, and start removing the formwork as you go. That's it. This is under compression. Now you can start loading it. You want to load it fairly balancedly, so balanced-wise, you do this, and then this, then this, then this. You wouldn't just go. That's why you see bridges when they're working on this type of bridge. They'll be working from one side to the other side equally. Not because they're trying to get it done, but you need to keep the balance on this, or you throw it off. Comments. Let's see. Why didn't have OSHA inspections on site? Well, OSHA only works for they do the no, they wouldn't be on site. So they come in afterwards when you got a complaint or a safety complaint, a violation that you could mention. And the next, Danielle, I think the deck pulled away as it started falling. Deck pulled away. I do one sentence at a time here. It pulled away, and you can hear me thinking. It pulled away as it started falling, then halfway down, pushed back, and hit the column. Well, I hope that's what I said, because, you know, I'm going to share something with you guys. I love the amygdala, and I keep trying to force people to go look at it. The amygdala is behind our ears, 2 parts of our brain. This works with everything we do. The amygdala is what everybody says the primitive brain. BS. It's the primary. It's first things first. We get it first. Now let me see if I can prove that to you. When I say troll, I'm going to try to inflame all of you. And so I'm going to insult you. So by insulting all of you, a universal insult, all of you take it the same way, as an attack. The amygdala deals with fight or flight, right? So fight or flight, that's how it responds. And it deals with attacks. So if I insult you and you want to come back at me, well, then you took my insult as an attack. And your response, therefore, is amygdala response, because you couldn't resist it. Those are people who have short tempers that flare up. Now watch how simple this is. I have on my other videos, I explain it on my other channel. I have a great series of videos. Thank you. So I have so we make files. So right now, this is what I'm doing and what you guys are doing too. So let's jump with my man, Cousin It. Cousin It asked me a question, so about something personal. So he has a conclusive file down here, let's call it. And it may be what he thinks I do or whatever, or maybe he's doubting me or trolling me, whatever. It's a conclusive file. And he wants to prove his file. So he needs source data, source files. And this is the way, this is even with the bridge, this is everything. We need source files. So he asked a question, one question. That leads to another, and another. And then maybe he doesn't come to the same conclusion he's thought of when he starts getting all these answers. So then he makes a new conclusive file. Here's the thing. Once we make a conclusive file, once we decide that this is the way it is for any topic, and we can make multiple conclusive files, incidentally, on the same topic. Once we make this, it's protected by the amygdala. The moment you change, let's go with Danielle. Let's jump back in. So Danielle said what she thought it was. Once she says that, it could, I read it, I realize I know I'm being attacked, so I gotta give Danielle's source file some thoughts and see if it comes to the same conclusion as mine, or did she come to a conclusion that I should investigate also. Now, this is the way it works with everything. You tell me what you got going on in your life. I'm telling you, your conclusive file is what snaps you, and you just got to figure out what your source files are at. Now, you can never attack somebody's conclusive files. You can't ever say, you're wrong. That's just attack. You can never say you're wrong to somebody. You have to say, hey, okay, that's what you, tell me how do you get to that conclusion? How did you get there? And if they tell you all their answers and you see where they made a mistake, you can say that's wrong right there. No, you don't say that's wrong. You need to help them change this conclusive file up here. You need to change them the source file rather. You need to change the source files, help them change it. If you can't help them change it, walk away. Some people have an agenda that you'll never be able to change them. All right, I'm all hair. Whoa, I'm bald-headed. Okay, I'm impossible to tell from the video which fell first. Yeah, Mark, that's where I am. I can tell you what happened after the collapse. The beginning of the collapse, I think 10 is totally in place. If 10 is in place, Mark, we can only put the failure, okay, so that's a good question. That means we can only put the failure to the north side of 10. So let's go ahead and jump for that for you real quick. We can only put it the north side. And let's do that, put that back in. We know that there's no buckling in 11. And the buckling usually is in the middle. In this case, we're going to assume it's in the middle. And I'm saying that because it leaves it open for you guys to give me different data, different source files, so I can adjust that if that need be, my statement. So where are we now, Mark? Great live stream, just subbed. Ah, thanks. I'm going to say Hunt. Okay. You rock. Did I say it right? Cousin It. Is it they fell faster or more force? Is that a valid? All right, so I shared with another guy talking about stuff falling. Does a bowling ball and a feather fall at the same, and I specifically said that so you can have something to Google. A bowling ball and a feather, do they fall at the same rate? They do not. Nowhere in the world do they fall in the same rate unless you put them in a vacuum. You put them in a vacuum, they fall at the beautiful same rate. Google that, find it on YouTube. You guys will be so amazed. I don't know how much those people paid to get hold of that NASA vacuum tank. It is the prettiest sight to watch a bowling ball and a feather fall at the same rate. So no, the heavier mass will always fall the resistance. It's about resistance. So, and the heavier mass. So the heavier mass will have least resistance compared to the top one. And nevertheless, we got different forces going on here. So it's not the same. They have to separate for us to come to that answer. So in other words, it's not relevant because these were together. They were pulled together, stayed together with the post-tension longitudinal cables. All right, what do we got here? Patrick, what if they had put the canal portion? You know, Patrick, their argument's going to be, I think, is that this bridge was not complete, which is not a really good argument because then you should protect the public. That would only difference, Patrick, and this is what I'm glad you're asking. This video works out great. And Danielle, you listen to this. So the only difference between that bridge and the put together is only the top canopy's longitudinal post-tension cables. That's what would have tied it in further. Local. It's my fault. So now back to the question, which I lost. Small brains, what did I say? I got a small train, I lost track. Where did we go here? We had a question about what if they had put the canal, nope. Fell faster. Yeah, so we can only fall, we know that all of this from the north side over was together. There was nothing going on. So we have forces down here. that are the issues that we have to come up with. And we all wanted to say that the post-tension created it. But we got cracks. We got concrete structure. We have imbalance for sure in these node systems. But it stayed together. It stayed together. We know now that the bottom of 11 per this expert, and I'm being facetious now because I don't want to say expert, somebody's not going to subpoena my ass. So this opinion of how this action took place here. So all the J-hook being in place and all of that, it's good. So what's my man over there? Structures and all. I swear he's following me here. So if you're in here watching, man, here you go. Don't be afraid to speak up. I just messed with the one guy over there in one of my videos. I just found it. I was getting inflamed by you guys saying that this sheared off. That was my trigger because we had the same source data. All right, so there we go. I finally found something. So we all had the same source files. I came to a different conclusion. They, in turn, were saying something contrary to my conclusion. So I felt attacked. So I made a video on it. There we go. Okay. And so, as I said, we don't know sometimes when we react. And there we go. So Hermit, yes, old school. The Roman dome was 5 times heavier. Yeah, I don't know the way the Roman dome. Well, they tried to build. Yeah, it's amazing, isn't it? I don't know. How do you save face on that? How do you go? You're not going to go back to the government, are you? And what are you going to name it? You going to name it after the people you killed? That's a tough one. In honor of the people we killed, here's our bridge name. Somebody wrote me, I think it's P25, said that, or was it another guy, said that the school president got $100 grand raise. He put in the comments, I think. And the walkway pulled the canopy apart in tension. The initial failure in the walkway. See, now I might be getting. He's attacking my conclusive files. Let me see. The initial failure in the walkway pulled the canopy apart in tension. Now you're describing pulling apart, right? So this is what I see you describing. So I'm not trying to troll you, but you're describing something pulling apart. You can't. It's pinned on each side. We have no shear moment going on. If we're to pull apart, you need a force to pull it apart. Now, I don't know if you mean this. Let me help you out. I'm going to try to save you, right? So this will be tension. That's a tension break, right? So the bottom is in tension. Even though this is under compression, the bottom of this is in tension also in concrete. So don't get it confused that you can't get tension. This is compression now top. That's tension down there. And let's see what we got here. I guess I'll read the rest of your sentence now. The walkway had to shear everything in the concrete. Took longer. I'll leave that alone, okay? It's based on the statement I just wrote in the video. You might have to go back and mark on that one. The whole bridge is a shear because of this crack here that we don't only have evidence of down here in the photograph. Pellin, they just need to. Well, they had too much. They're too big to fail. That whole video I did about that you're going to bad. You're at the engineering school bragging about to be the top dog in the world, and now your design, which I did look up the engineering school guy. He said this is going to be a long term of FIU. That engineer guy. He's about 63 years old now. The article was 5 years ago. No, he was 57 then, and I felt like it was 5 years. So he was bragging about they had monitors in here. They were going to have monitors in place, monitor this bridge long term. It was going to be their school project for like forever, right? With that said, I don't think the monitors were in place, or maybe I don't think so. Cortez, right? So yeah, there's nothing they could do. Temporarily support this bridge and fix it. I don't know how you get around to fixing all that. It's too much dynamics. Who'd want to put their name on that? Number 11, the canopy. That's why it appeared to fall fat first. They stayed together. 11 stayed together. Remember, we have the impacts. 11 and the canopy stayed together. If to imply so they needed an action down here. This needed a lift off. Remember, we have photographs showing that we have the back of 12, bottom of 12, bottom of the back of the deck. We have PVC pipes that appear to be undamaged, save one that's got a little bend in it. So to get 12 off of this without shearing off, you create, and I guess maybe, again, you create this hinge action. Now it lifts off. Lifts off the rebar, lifts off that. And when the bridge is the push-pull thing, it pulls away, and then it goes down again. And then we go down again, and we wind up like this. Now at one point, if we're here, you can see the separation up here. It did hit there, and now we got a disintegration. We're going to have to have some more breakage there as this settles down on top of the blister bar. And they rotated together, obviously. Remember what pulled this over was the weight of the rest of the, let me give you a little better image, was the weight. Danielle, you thinking about my house? Listen, so it was the rest of as this pulled over, was the rest of this south side that pulled this back because it weighs more. It's just drag that. The post-tension rods, the longitudinal post-tension cables kept it together. And there we have, and it's sitting on the pylon, so this pushed over a little bit. Yeah, I told you it wasn't a scale. So anyway, that belongs over there. What we got? Questions by? No redundancy. Yeah, you're never going to get redundancy in concrete. You know, you got some. You try to counter the well, let me correct that. I can probably make up a story for redundancy. So you put your walkway on the ground. That's the level that's holding it. The sub base that's holding the concrete. Now we add redundancy. We put in rebar, you put in wire mesh, things like that. Not things like that. Those two you'd put in steel. You put in some steel. Oh, post-tensioning too, out west, where they have expansive soils. Now you don't need to put in rebar if your sub base is totally stable. There's no water is going to wash it out, etc. It's 1-for-1. You're going to put your load on top of the concrete. It's going to transfer directly onto the surface below. Okay, CSX Baltimore. That's a train, right? CSX subdivision. Great job. They should hire you. No, I'm a person that comes in, resolves problems in my job. So this will help out. This will help. In other words, I'm not for hire like that. A lot of people try to hire me. Cousin It, right? So there you go, Cousin It. CSX got it out of me. Something to add to your file. No, this is what I live for. Something like this, and then I move on. I like sharing, though. I do like. That's why the other channel I have. I like sharing a lot of stuff, educating. But you know, this is clearly. I'm gonna defend this with anybody, not just defend, because I don't mean defend as inclusive file. Because remember, I need to stay flexible. I have it here. Anybody can. It's open for anybody to give me a new source file, so I can come to a new conclusion on anything I said. And that's what I said. I always go with the data. This is the number one. Something crazy saying this is the reason why, and, you know, obviously doesn't make sense. There are a lot of problems to fix there. Yeah, it was just bad conception. It was bad at conception. Again, a concrete bridge. So there is no way this bridge design could have ever worked. Danielle, I would love for it to work. I like your floor. I've got to sand all this. You know, it's maybe I should put it on the other channel. Ultimately, I'll give you a little something, Cousin It, this is for you. So I buy and sell real estate. You're allowed to keep a house for 2 years as your primary. After 2 years, you sell it, and you get to keep all the capital gains, tax-free. So I always find a primary, and I always take about 2 years to finish it, because why would I finish it ahead of time, right? Besides, when you go to sell it, you can now tell them the service life is just finished, 3 months prior. So there you go, Cousin It. All right, so thanks for the floor, though, although I tore out, this house is huge. It's 10 bedrooms. It's friggin' huge. Don't think so. The bridge is a cluster. Yeah, I don't want Google to put us in the adult section. But yeah, I love what people said what FIU was, right? FIU, people come up with some good abbreviations. You guys can write it. I can't say it. Or Google put me on the beatdown list. What you got here? Give me a second. I gotta actually charge this phone up. I'll put the plug on. I don't think it's gonna die, but preventive medicine. All right, what you got there for me? Well, the replacement of, yeah, I wish. They should just do a walkway. Oh, the problem with the original design was it didn't allow for, I think, looking at the design, I don't think it allowed for emergency vehicles. It allowed two-way traffic each direction without a lane for emergency vehicles. That's very important. You guys want to talk about that 2-hour meeting real quickly they had? Denny Pate would have been the head dog there. He would have been the one that said post tension. Nobody could have gone over him and said, post tension it. The moment they did that, they would have become the primary builder and the primary responsible person. No one in the right mind would say do it. No one in the right mind would say do that besides Denny Pate.